Okay, let me share my screen. Good morning, everyone. So, one second, please. Yeah, I hope my screen is visible. Okay, this is a second demo that we are going through. Okay, who are new. Okay, my name is Shiva. So I have 8+ years of experience. I work with multiple technologies in DevOps as well as in development, in developing Java-based applications. So yeah, this is my short introduction. Yesterday we went through some of the course details and what are the prerequisites that is required, some of the things that we went through. That video is available as a playlist in the YouTube. Please, who are and all the new, you can go through that in the YouTube. Okay, so it's there in the YouTube. Okay, so what we are going to discuss today is about these things. This is our agenda today. That is, what is DevOps? What is DevOps? What is an application that we call it as? What is SDLC, software development lifecycle? And what is a server? What is a server? What is a physical server? What is a Docker and Kubernetes? Where does Docker and Kubernetes in software release process? These are the things that we are going to see today, actually. So what is DevOps? What is DevOps? DevOps is a combination of development as well as operations. Okay, development, it does not mean that we develop applications in DevOps. Okay, we develop scripts. We develop some scripts to automate the deployment of infrastructure. That means in order to deploy an application, in order to in order to make that application available to all over the world. Suppose Amazon.in, anyone can access that application, right? How you can access that application? That application is put on servers, okay, so that it will be accessible to everyone in the world. That servers is called infrastructure. In order to run a particular application, whatever it is, like it's Amazon or Myntra or any application, it requires some infrastructure, something called servers. It requires disk space. It requires NFS, network file system, something like that. Okay, creating the scripts in order to deploy, in order to create the infrastructure, in order to deploy our applications on that infrastructure is called development that we do in DevOps. And we also need to know some kind of application functionality from the developers in DevOps, so that it will be very easy for you to perform required things in the DevOps activities. And operations, what is operations? We deployed an infrastructure, that means servers. We have created a servers in the cloud or wherever it is. Maintaining that server, something, providing security updates regularly, providing deploying different versions of the applications at regular intervals of time. Whenever a new version has been created by the developers, you need to regularly deploy that applications onto the servers, onto the infrastructure. That is the operations that we perform. If any issues occurs on the infrastructure, you need to solve them. Such kind of activities are part of the infrastructure operations. That means such kind of operations are part of this operations in DevOps. So DevOps is a combination of development as well as operations. Development is something we develop some scripts in order to deploy the infrastructure, and operations is something we maintain that infrastructure, is called operations, that in DevOps. Okay, DevOps contains many tools. It's a combination of tools to automate the infrastructure, and to automate our regular activities, manual activities, actually. So each and every stage in DevOps contains many tools. Suppose in case of deployment stage, okay, we have Docker and Kubernetes. In case of automating the deploying of application onto the servers, we have Jenkins, GitLab CI, something like that. Okay, in each and every stage in DevOps contains tools. Okay, so few are there popular and few are non-popular tools are there, but tools are there in each and every stage of DevOps. Actually, DevOps is a combination of development and operations. So each and every stage contains tools. Okay, so that is DevOps. Okay, what is an application? Okay, what's an application? It's something, a website. Okay, we regularly in our day-to-day, we regularly access many websites in a web. whether it's Redspot.in, whether it's Amazon.in, or anything IRCTC. So these are all different applications. Applications is nothing but, in simple words, it's a website. In simple words, it's a website that is developed by developers and deployed by DevOps engineers. Okay, so that is an application. Application is a, in simple words, it's a website that we regularly access in our day-to-day life in order to perform any action. Okay, that's the thing. What is an SDLC? SDLC is, the full form is Software Development Lifecycle. You people may know already, because yeah, that's the thing. Okay, that's a basic one. Okay, the SDLC, what is it? When this SDLC is used for? Okay, SDLC is used to, it's a process of developing and deploying our applications or like onto the servers. Actually, it contains many stages, 6 stages it contains. First stage of like SDLC process is called requirement phase. In the requirement phase, what the people does, what's the SDLC? SDLC is a process that we follow in industry to develop and deploy applications onto the servers actually. So that's the SDLC. There are 6 stages in SDLC. First stage is the requirements stage. What we do in this requirement stage is we collect the requirements. How many people are needed to deploy until like developing, deploying, testing, until the deployment of this application onto the server. How many people are needed in order to complete the end-to-end of this application? Okay, such kind of requirements we'll collect. How many servers are required, and what are the infrastructure is required, and something like that. We collect requirements in requirements phase. It's the first phase in SDLC. This is the one. This is the analysis phase or requirements phase that we call it as. So we collect requirements as part of analysis or requirements phase. What is the requirements is something like this. Okay, so what I've explained. So next phase of SDLC is a design phase. Okay, there will be a system design. There will be a something called like system design. We have design patterns. We have multiple design patterns that the industry follows to design a particular application. So in simple words, what I can say, suppose if you log in, if you want to visit any application, first you need to enter your username and password, like if you want to log into any application, right? Okay, so where that username and password should be there on the page, whether it should be on the middle of the page, whether it should be on the top of the page, whether it should be on the bottom of the page, bottom of the web page, I mean to say, on where the username and password should be there on the web page. Such kind of design that we do in design phase. And there's a complex design also, that is something called design patterns we follow, and we design the application. So it's something, in simple words I'm saying, where the username and password screen has to be appear, whether it's on the top of the page or bottom of something like that. Okay, the design will be happening. So that is a design phase. Okay, development phase. In the development phase, in case of SDLC, what the people does is, people will be selecting one programming language, whether it's a .NET, whether it's a Java, or any other programming language that suits their customer requirements. Okay, that suits the application customer requirements. Okay, so they will choose one programming language and they will start developing the application. They will start developing that application with the chosen programming language. Okay, that is the development phase. In the development phase, developers also will write some unit test cases. Unit testing they will do in case of development phase. Okay, that is development. Okay, the next phase of the SDLC is testing phase. Testing phase. There will be a separate team for this. So testers will be there. So they will be testing the application, or like the developed application that is developed by the developers. Okay, that how, like, we have different types of testing, like something called performance testing or smoke testing. So different types of testing things are there. So they will consider those strategies and they will perform those strategies on the developed application by the developers. They'll perform testing on the like developers. Okay, they will be having some test cases, they will perform some testing on the developed application by the developers. Actually, that is testing phase. Here is where deployment phase, here is where our Docker and Kubernetes comes into picture. Actually, whatever application that is developed and tested by the testers should be deployed onto the servers. So here is where our Docker and Kubernetes comes into picture. The way we are deploying, the way as nowadays, the way the industry is deploying applications onto the servers is using Docker and Kubernetes. Here is where our Docker and Kubernetes comes into picture at the deployment phase in the SDLC process. Actually, so that's a, here is where the things comes. Okay, now maintenance phase. Once the deployment is happened onto the servers, we need to maintain that application that is present on the servers. Like, we need to regularly update a new version of the application that is given by the developers. We need to regularly like provide security updates to the infrastructure, like Indeed infrastructure. So that we perform, that such kind of operations we perform, we will maintain the developed and deployed application onto the servers by providing some, if any issues occurred, by providing some solutions for them. So something like that. Okay, so that is maintenance phase. So okay, these are 6 phases in SDLC life cycle. So at part of deployment phase, our Docker and Kubernetes comes into picture. Okay, at part of deployment phase, our Docker and Kubernetes comes into picture. The way the people are deploying their applications into the servers is using Docker and Kubernetes. It's a most popular tools as of now, as of today. So that is Docker and Kubernetes. Okay, it comes under deployment phase. Okay, so what is a server? So server, suppose you have developers have developed an application, whatever programming language it is, they have developed an application. So in order to make available to all the users all over the world, what you need to do, you need to place, you need to deploy, you need to put that application onto the servers. Okay, you need to put that application onto the servers. Okay, so the deploying, that is called server. Okay, server is a it's a, with the different types of servers are there are physical servers and virtual servers are there. So let's think one server as of now. So we need to put that application onto the server so that this application will be accessible to anyone in the world. Actually, that is a server. Server makes our application to accessible anyone in the world. That is a server. Okay, now where does Kubernetes and like Docker and Kubernetes fits in SDLC process? I'm not talking about Jenkins, but we have a separate lecture about that. Okay, where does Docker and Kubernetes fits in SDLC process? So in SDLC process, Docker and Kubernetes fits in deployment phase. That's the thing. Okay, now we have in the previous times, in few years back, we have something called physical servers. Okay, people have like people will be using that physical servers to deploy their applications on them. Actually, so we have different disadvantages in order when we deploy applications on the physical servers. Let's see one by one. Okay, so suppose this is a physical server. Okay, this is a physical server. What is a server? Server will make our application to access all over the world. Actually, that is server. There are 2 types of servers. One is physical servers and virtual servers. Actually, so let me put it here. First one is physical servers, and second type of servers were virtual servers. Okay, now what, suppose in the previous times people used to deploy their applications onto the physical servers. Suppose this is a physical server, this is a physical server. let me put that here. Whatever operating system it is, whether it is a Linux, let's think it's a Linux operating system. So okay, this is the physical server. Okay, this is a physical server. We have deployed an application on this physical server. We have deployed an application. We have put our application on this physical servers. Now, this physical server will be having some resources. What are resources? Resources means CPU and memory. So like something like that. This physical server has 10 CPUs, like CPUs are 10 for this physical server. Okay, this is first, like, and memory that is there with physical server is 10 GB memory, 10 GB memory that is there with this physical server. Okay, this is a physical server. Let's consider this is a physical server. Okay, there are two, like, we have two physical servers, like, this is a physical server. Okay, this contains 10 CPUs and 10 GB of memory. This contains 10 CPUs and 10 GB of memory. And our application that is deployed in the queue, like in this physical server, only require, suppose, let's think one CPU, one CPU and 1 GB of memory, 1 GB of memory. Okay, only require, my application is only required one CPU and 1 GB of memory in order to run that application on that physical server. Now, this is a physical server. Why the people went out of physical server and deploying their applications onto the virtual server? Okay, virtual servers actually. So what are the disadvantages that we have regarding the physical server? Let's see one by one. Okay, here with physical servers. Okay, disadvantages we have with physical servers. Okay, physical servers is, suppose, as I mentioned, suppose my physical server has 10 CPUs and 10 GB of memory, and my application is only required one CPU and 1 GB of memory. What about remaining 9 CPUs? See, whatever remaining is 9 CPUs. One CPU and 1 GB of memory is used by my application, and remaining CPUs are 9 CPUs. 9 CPUs are there. Again, memory is, we have 9 GB memory. We have 9 GB memory. Okay, 9 GB memory. We have remaining CPU and remaining memory this much. This is the resource wastage, the first disadvantage that we have if we deploy our application on the physical server is resource wastage. Okay, resource wastage. Okay, so if we have I have deployed my application. My application only require one CPU and 1 GB of memory, and remaining 9 CPUs and 9 GBU is 9 GB is resource wastage that we have in case of physical servers. Resource wastage. Okay, the first disadvantage in case of deploying our applications on the physical servers is resource wastage. Okay. Resource wastage. Now this is the first disadvantage. So what is second disadvantage that we have? Okay, what is second disadvantage that we have? Suppose a problem has been occurred in physical server. A problem has been occurred in physical server. A problem has been occurred in physical server, and it got crashed. The application which is running inside the physical server will also be getting crashed if the physical server is crashed, and it is not highly available. No high availability is there. In case of virtual servers, if one virtual server has been killed, a new virtual server will be automatically created and the applications will be automatically deployed, but not in physical servers. If one physical server is is been killed, once one physical server is, suppose let's think this physical server has been crashed or killed or wantedly deleted by someone which is running our applications. So in that case, our applications will not be accessible to anyone in the world because this physical servers itself is crashed. That means there is no high availability for our applications. So no, the second disadvantage that we have in case of physical servers is less higher, no high availability. What is high availability means, if a server is killed and if an application is killed, automatically a new server and new application should be created automatically. So that is high availability. But in case of physical server, we don't have that. Okay, high availability, and this is a second disadvantage that we have in case of physical server. Okay, what is third disadvantage that we have in case of physical servers? Okay, so I have 100 applications to be accessible to everyone in the world. I need to buy 100 physical servers to deploy those applications. To deploy the 100 different applications, I need to buy 100 physical servers to deploy them. So, if I want to buy 100 physical servers, it's a huge cost, right? Not only physical servers for that applications, we need to buy some space, disk space also we need to buy, something like that. Okay, so it's a huge cost for me in order to buy the 100 physical servers in order to deploy 100 different applications. So the third disadvantage that we have is huge cost actually, huge cost. This is third disadvantage that we have in case of physical server. Okay, what's the next disadvantage? What is the next disadvantage? Suppose I have 100 physical servers, my 100 applications are running in 100 different physical servers. So there should be a separate team to maintain that physical servers. There should be a separate team to that maintain to the physical servers, like providing regularly security update, deploying regular applications to that physical servers. So there is a huge maintenance in case of physical servers. Okay, suppose if you want to place this physical servers, you have your own physical servers. Let's think you have 100 physical servers. You need big data center to deploy, to put that physical server. You need air conditioners to support that physical servers. So it's a huge maintenance that we have in case of physical servers. Okay, that should be maintained by particular in organization or particular company. So that may not be feasible solution to use physical servers. Okay, high maintenance. Okay, high maintenance is there in case of physical servers actually. So these are like, there are many disadvantages. These are the main disadvantages that we have. Okay, resource wastage. Okay, and no high availability. If one physical server has been killed, automatically a new physical server has to be created, but it will not be happening in case if we deploy our applications on the physical servers. Okay, so there is no high availability. And if you want to deploy our 100 applications onto the physical servers, we need 100 different types of physical servers. If I want to buy 100 physical servers, it will be costly for me. Okay, that is huge cost is the next disadvantage, and high maintenance in order to deploy, in order to put, in order to place these physical servers in any data center. We need a big space, and we need some kind of supporting things like air conditioner. So we need something like that, and we need a separate team to maintain that physical servers. So that is high maintenance we have. Because of these disadvantages that we have in case of physical servers, we went to virtualization. Okay, because of these disadvantages that we have in case of physical servers, that is the reason we went to virtualization. That means no, industry went to virtualizations. You can ask if you have any questions, please. Okay, okay, so let's continue then. Okay, so Yeah.
Excuse me.
Yeah.
Excuse me, sir. Yeah.
Yeah.
This physical server you mentioned, right? For single
Yeah.
application, I mean, so organization used to buy individual server, or using individual server, they can deploy multiple application. How it will be?
No. They will not deploy in case of physical servers. They will not deploy multiple applications in the one physical server, because if one physical server has been killed, I have deployed. Suppose let's think I have deployed 100 different applications on the one physical server. If one physical server has been killed, 100 applications will not be accessible to anyone in the world. All the users will be affected. It's a huge business impact for them, right? So what they will do, they in case of physical servers, they want to deploy 100 different applications in 100 different types of physical servers, so that it will not be risky kind of thing for them. If one physical server is crashed, also other physical servers are there on which their applications are actually running, so that users will not be mostly affected actually. So they will deploy individual application on individual physical server actually. That's the thing.
Okay. And one more thing, sir. In the
Yeah.
SDLC, you have mentioned like maintenance part.
Yeah.
Security means what? Like how? That point I did not clear.
Actually, there are different packages. Suppose we need a servers, right, in order to deploy our applications onto the servers, right? So servers will be having some security. Servers will be having some firewalls. So who has to access this application? Who do not have to access this application? Some firewalls will be there. Some packages will be there. Such packages like Yum package will be there, or Nginx package will be there. So those packages may be having some bugs which will allow which will allow people to access, like unauthorized people to access the applications in a bad manner. So if someone find that vulnerability, such kind of things are called bugs or vulnerabilities. If someone find that vulnerabilities, the server who has created, suppose let's think Ubuntu server, who has created the Ubuntu operating system, they will release some patch update. So in order to remove that security vulnerability, they will release some patch update. Being the people who are maintaining that physical servers, he has to release that patch update to that servers, so that the unauthorized people will not be accessing that application. That is the kind of security that we do in case of maintenance phase actually. Yeah.
That is not part of this DevOps, right, sir?
No, it's part of DevOps. We
Oh.
need to regularly update the things actually.
Okay.
Yeah. So it comes under operations phase. We have two things, right? Development and operations. In DevOps, it comes under operations. Okay.
Okay, sir. Thank you.
Yeah. So these are the different disadvantages. Yeah. Anyone have any questions, please? Okay, so these are the different disadvantages if we want to deploy our applications onto the physical servers because of these disadvantages. So we have something called virtualization. What is virtualization? The process of creating multiple machines on one physical machine. Physical machine means physical server. Okay, physical machine, physical server is same actually. The process of creating multiple machines on one physical machine is called virtualization. So let's draw a diagram. Okay, suppose this is our physical server or physical machine. Okay, let me put it here. Physical server. Okay, this is physical server. This has the same thing, same resources we will take. CPU is 10 CPUs that we have. Okay, 10 CPUs that we have, and we have memory for this. Is 10 GB memory that we have. Okay, let's put it here. We have 10 CPUs and 10 GB memory for this physical server. Actually, on the physical server, in the virtualization thing, what will happen is, so we will be having something called operating system in this physical server. Operating system, whether it is any operating system. Okay, so any operating system, like there are different operating system in the world, right? So it's a like it may be Ubuntu, it may be CentOS, it may be Red Hat, or it may be Linux, or it may be Windows, or it may be Mac. Any operating system that will be there on the physical server, but mostly industry uses to deploy the application. Industry uses a Linux operating system most of the time, actually. So until and unless you have particular requirement. Okay, so this is operating system. Okay, this is operating system that is there, actually. Now on top of this operating system, what the people has did is they have installed something called virtualization software. Okay, something called virtualization software. Okay, let me put it here. They have installed something called virtualization software. There are different virtualization softwares available in the market, actually. Suppose, let's think VMware. VMware is one of the virtualization software. What this virtualization software does, let's discuss. But there are, as of now, there are multiple virtualization softwares available in the market. Okay, something called VMware or VMware VirtualBox, something like that. Okay, there are different. Hyper-V is one of the one. So something like that. Okay, so virtualization software that is installed on this physical server. Let's think this is called Hyper-V. Hyper-V. Okay, Hyper-V is a virtualization software that is installed on this physical server. Okay, let me put like this. Okay, what this virtualization software does, what is the functionality of this virtualization software, what it does for us. Okay, so what this virtualization software does is it will divide one physical server. It will divide one physical server like this into multiple servers. Okay, it will divide one physical server into multiple servers like this. Okay, these servers are called virtual servers. Okay, this server are called virtual servers. Okay, this, see, there is a physical server. On top of physical server, there will be a operating system. On top of operating system, there will be a virtualization software that is installed. What is the functionality of this virtualization software? This will divide my physical server into multiple server. Those are called virtual servers, actually. Those are called virtual servers. Let me put it here, or it's VMs. Okay, we will call it as VMs. Okay, VMs is called virtual machines. Okay, virtual machines. Okay, VMs. Okay, in our course, whatever it is, whether it is a Docker, whether it is a Kubernetes, or whether it is a Jenkins, we are going to deploy those softwares on these virtual machines only in the AWS. But like you might have understand as of now how the structure will be. On the physical server, there will be operating system. On the top of operating system, there will be a virtualization software. That virtualization software will help us to divide my physical server into different servers like this, and those are called virtual servers. Those are called virtual servers, actually. So these are called virtual servers. So now industry started deploying their applications on the virtual servers. Actually, industry started deploying their applications on the virtual servers. What happened is this physical server has 10 CPUs and 10 GB of memory. Now that will be divided onto all these things, actually, on all these virtual machines. Okay, suppose this virtual machine contains this 10 GB, like this 10 CPUs and 10 GB memory is divided actually to all the three different virtual machines. Okay, now this first virtual machine contains CPU is 3 CPUs contains, and memory, just I'm taking an example. Okay, memory it contains is 3 GB memory. Okay, 3 GB memory. Okay, it is divided like this to the first virtual machine. Okay, so now what this 3 CPUs and 3 GB memory will be taken from this physical server only, because that is virtual machine is there on the physical machine only, physical server only. So that is why this is taken from this the resources from this physical server only, that is taken from there only. So now this second VM also has CPUs are 3 CPUs and memory that we have is 3 GB memory, 3 GB memory. Okay, now the third thing, the third virtual machine also has CPUs are 3 CPUs and memory is 10 G like 3 GB memory. Okay, uh, okay, okay, 3 GB memory that we have. Now remaining 1 GB of memory, this 9 CPUs will become and 9 GB memory will become, right? Remaining 1 GB of memory is consumed by, let's think it's consumed by virtualization software and the operating system that is deployed on the physical server. Okay, so that's how it works actually. So now people started in industry, people started deploying their applications on the virtual machine. So they have deployed their applications on the virtual machines like this. Okay, this is something called, let's name it as application 1. Okay, let's name it as app 1. Okay, app 1. This is another application that is deployed on the second physical machine, second virtual machine, that is app 2. Okay, app 2. Okay, let's think this is app 2. Okay, there is another application that is deployed on the first physical machine only. Okay, now this application is called app 3. App 3. Now if we deploy our applications like this on the virtual machines, if the industry deploys these applications like this on the virtual machines, what are the disadvantages that we have and what are the disadvantages that we have with physical servers that are remote, and what are the disadvantages that we have if we deploy our applications on the virtual machines like this? Let's see one by one. Okay, now in case of resource wastage, suppose my application 1 is wants my application wants app1 application 1 wants 1 CPU and 1 GB of memory of memory. Okay, my application 1 requires 1 CPU and 1 GB of memory. Okay, in the same way, my application 2 also requires 1 GB of 1 CPU and 1 GB of memory. Okay, and in the same way, my application 3 also requires 1 CPUs and 1 GB of memory. Okay, now in case of this, okay, if you see virtual machine 1, this is the first virtual machine that we have. If you see the virtual machine 1, okay, 1 CPU and 1 GB of memory is consumed by each application. There are 2 applications that is on the virtual machine 1. They are application 1 and the application 3. Okay, 1 CPU and 1 GB of memory is consumed by 2 different applications. Okay, now there is a resource wastage that we have in case of physical servers actually. Okay, now the remaining 1 GB of CPU and 1 CPU and 1 GB of memory is resource wastage. Resource wastage is still there in case of virtual machines. Okay, in case of virtual machines, the resource wastage is still there. Okay, let me put that point here. Resource wastage means the CPU and memory wastage. What is the resource here? CPU and memory. Okay, if you have any questions you can ask. Okay, okay, resource wastage that is still there in case of virtual machines. And this is the first disadvantages that we have in case of, we have seen in case of physical servers. The same disadvantage that we have also have in case of virtual machines. Now no high availability is a second disadvantage that we have in case of physical server, right? Now in case of virtual machines, what it will be there is, in case of we are going to provision, we are going to create these virtual machines as part of AWS, Amazon Web Services. Okay, now if one virtual machine has been killed, the Amazon Web Services will provide a way to automatically create a new virtual machine, and automatically deploy my app 1 and app 3 to that virtual machine. So that is a disadvantage that is removed from the, if we deploy our applications on the virtual machines. Suppose if this virtual machine is crashed, my application 1 and my application 3 will also be crashed, right? So in that case, what the Amazon does is, Amazon creates automatically a new virtual machine is created automatically, and our applications which are already running on the crashed application will be deployed again to the created virtual machine. Okay, so that is the high availability that we have in case of deploying our applications onto the Amazon virtual machines, okay. We will be having something called availability zones. So that's a different concept. As of now, there is a high availability if we deploy our applications onto the virtual machines actually. So that disadvantage that is removed in case of if we deploy our applications onto the virtual machines directly. That is the disadvantage that is removed, okay, in case of virtual machines. Now, huge cost. Okay, in order to deploy my application, suppose we have thought, like, if in order to deploy 100 different applications in case of physical servers, we need 100 physical servers in order to deploy 100 applications. But in case of virtualization concept, in one physical server, as we are going to create in one physical server, we can create multiple virtual machines. You can deploy that applications onto the virtual machines, right? So instead of buying 100 different physical servers to deploy 100 different applications, we will be only buying the one physical server, and we'll be deploying 100 applications onto this physical server. Anyway, high availability is there, because if one virtual server has been crashed, a new virtual server is automatically created, and automatically our applications are deployed onto the virtual servers by the AWS. So there is a high availability, and there is a less cost that we have, because instead of buying 100 different physical servers, we are only spending our money for only buying one physical server only. That is the less cost. Like, that's the cost disadvantage has been removed if when we consider to deploy our applications on the physical, like on the virtual machines instead of physical machines or physical servers. That's a thing actually. Now that's gone. Okay, huge cost is gone. Okay, now the next disadvantage that we have assumed in case of deploying our applications on the physical server is high cost, high maintenance. I mean to say high maintenance, right? So instead of maintaining 100 different physical servers for deploying 100 different applications, we are only maintaining one physical server only. In case of if we deploy our applications onto the virtual machines or virtual servers, we are going to maintain only one physical machine only, instead of maintaining 100 physical machines. So the huge maintenance reduction is there in case of if we deploy our applications on the virtual machines instead of physical machines. I hope you understand what are the virtual machines, right? Yeah, okay. So that is high maintenance has been removed. Actually, in case of deploying our applications on the virtual machines actually. Okay, that's a thing. Now the resource wastage is the main disadvantage that we have in case of virtual machines. If we deploy our applications on the virtual machines, the main disadvantage that we have is resource wastage. Because of this reason, we went to Docker. We went to Docker. This is one of the reasons I'm going to say. This is the main reason, and this is one of the reason. So because of this reason, we went to Docker. The other reason why we went to Docker is the evolution of microservices in the industry. We will talk about microservices in soon, actually, in different lecture or in the same lecture, or okay, whatever it is, if time permits. Okay, now because of these two reasons, one is resource wastage, the second reason is evolution of the second reason. Let me put it here, evolution microservices. Because of these two reasons, the Docker is been popular. Actually, let me put these are the two reasons. These are the two reasons why the Docker has been evolved. Actually, let me put this one here and explain Docker. Okay, let me put like this. Okay, now in case of Docker, what we'll have is we will be having one physical server. Okay, let me remove this. 1 second.
So Docker is also virtual server?
No, it's not a virtual server. It's a software which will help us to deploy our application as a containers. Okay, I'll explain that. Okay, so
Okay.
yeah. So let's think this is the physical server. Okay, let's think this is a physical server. Let's think this one. Okay, this is a physical server that we have. On top of this physical server, we have operating system, as we have already discussed. Okay, and on top of this operating system, we have like virtualization software. What this virtualization software did is it helped us to create multiple virtual machines on one physical server, multiple servers on one physical server. I'm drawing only one for the visibility purpose. Okay, yeah, let me put it here. Okay, this is operating system. Okay, now this is the virtualization software. Virtualization software. Okay, this is the virtual machine. Okay, let me put it here. This is the virtual machine. VM represents the virtual machine. On top of this virtual machine, in case of deploying applications directly on the virtual machines, in case of Docker, what we will do is we will install software on this on top of this virtual machine is something called Docker. We will install Docker software in case of this virtual machines. Let me put it like that. Okay, let me put this one. Okay, this is a container runtime engine or software. Let's assume, because it's a not a time to introduce like container runtime engine, such kind of words, but yeah, just think it's a software that we install on top of virtual machine, Okay, what this software actually does, what the advantage of using this software is, it will make our applications to run as containers. What's a container? Let's discuss. But yeah, it's a like we will discuss, no problem. It will make our applications to run as containers. They are lightweight containers. Why I'm calling lightweight containers? Let's discuss in the course actually. Okay, so that will make our applications to run as containers. Suppose this virtual machine let me put it here. This virtual machine has where I can put 10 CPUs. Sorry, 3 CPUs. As previous example, we have taken 3 CPUs, right? Let me take 3 CPUs only. Okay, this virtual machine has 3 CPUs and 3 GB memory. 3 GB memory. Okay. Okay. Now, entire resource is properly consumed in case of deploying our applications directly onto the virtual machines. We have resource wastage, and in case of deploying our application as form of containers. What's the containers? Let's discuss, but as just assume our applications is deployed as in the form of containers onto the virtual machines, on top of virtual machines, using docker. Okay, now in case of if we deploy our applications as containers as part of docker, entire resource is properly consumed. Suppose, let's think, until the availability of the resources. Suppose here we have 3 CPUs and 3 GB of memory, and each application that I have deployed on top of docker as a container require 1 CPU and 1 GB of memory, and entire resource is properly used. In case of docker, entire 3 GB or entire 3 CPUs are properly used. In case of docker, there are many disadvantages that we are going to see, but just assume this is why we went to docker actually, from the deploying directly onto the virtual machines to the on like deploy, like from deploying the applications directly on the virtual machines to the docker containers actually. So that's the thing. Okay, now the entire CPU and entire GB memory has been properly used. Okay, now this is the advantage, and there is another advantages when we are going to discuss about the monolithic and microservices. I'll also tell that. Okay, let's complete this with the Kubernetes one. Okay, I'll tell that. Okay, no problem with that. But yeah, now we have another thing. Suppose, let's think, let me what I can do is let me copy this diagram. Copy this new. Okay, let me put it here. Okay, this is a way that we deploy our applications as containers on the physical virtual machine actually. Now, what is the disadvantage that we have with docker? What is the disadvantage that we have with docker is, suppose this container is been killed. This, what is a container? This, suppose, let's think, as of now there is like I have not introduced a word called container. And let's think these are the 3 different applications, or let me put app 1, app 2, and app 3 for easy understanding. App 1, app 2, and this app 3 actually. Suppose, let's think this application has been killed. This application has been killed in case of docker, wantedly or by mistake, or anyway this application has been killed. In case of docker, if this application has been killed, the users who are accessing this application will be affected. Okay, there is no way to recreate this application when something happens to this application. So that's a disadvantage. This is one of the disadvantages. There are many things actually, but let's think let's go in a step-by-step process. Okay, now let's think this one. Okay, if this application has been killed, there is no way with docker to recreate this application and to redeploy this application onto the docker or a virtual machine. This is the one of the disadvantage that we have in case of docker. Because of this disadvantage that we have in case of docker, because of this reason, we will go to Kubernetes. Okay, Kubernetes clusters actually. Now, in case of Kubernetes cluster, what we'll have is, we will have Kubernetes cluster is a combination of multiple virtual servers actually. Multiple virtual server. This is one virtual server. Okay, let's think this is one virtual server. Okay, let's think like that. Okay, let me copy one by one. Okay, these are three different virtual servers that we have in the Kubernetes cluster. What is a Kubernetes cluster? Kubernetes cluster is a combination of servers. Okay, there are three. Let's think these are three different virtual servers that are there with this Kubernetes cluster. Let me put this as a Kubernetes cluster. Okay, Kubernetes cluster. Now we have created or we have deployed our application onto this Kubernetes cluster. Onto this Kubernetes cluster app one, or and another application is deployed onto the second virtual machine. Let's name it as app 3. Okay, now Kubernetes is an orchestration technology. If one application has been killed, Kubernetes will automatically detect that, saying that there is an application killed has been happened on the uh, Kubernetes cluster, and it will automatically deploy the same application again. This is the advantage. This is one of the advantage that we will get in case of deploying our applications onto the Kubernetes clusters actually. So same application, right? Yeah, 3. So there are many disadvantages. As of now, let's stick to this because I need to explain the concept. Okay, there are many disadvantages that we have in case of deploying applications. We can follow different strategies to deploy our applications. So we can have different scheduling algorithms to deploy our application. So there are different things. We'll go one by one in case of our Kubernetes course, but let's stick to this here. In case of Kubernetes, if any particular application has been killed, a application will be automatically created and automatically deployed into the Kubernetes cluster. And if the virtual machine also killed, or suppose let's think this virtual machine also killed by wantedly or by mistake or by the anyone unauthorized person has been killed this virtual machine, a new virtual machine is automatically created and new application 1 will automatically deployed on that actually. So it's a container orchestration technology. Like, let's think, I'll say orchestration technology. What is a container? Let's discuss tomorrow as a time. So that's the thing actually. Kubernetes, this is how that functions. We have seen today what is physical server and what are the disadvantages that we have with physical servers, and how the disadvantages that we have with the physical server, how they are removed in case of virtual servers, and what are virtual servers, and what are the disadvantages that we have with virtual servers, and how the Docker is evolved, and because of what reasons the Docker is evolved. Because of these two reasons, let's think as of now, and because of these two reasons the Docker is evolved, and what are the disadvantages that we have with Docker, and why the Kubernetes has been evolved. So this is how we will going to follow in case of our course actually. So I hope you people understand. If you have any questions, please ask. Yeah, it's a time for asking questions. Please ask your questions if you have. Please go ahead.
Hello. Yes, sir.
Hello. Yeah.
I have some doubt. Like Kubernetes is also a software, like Docker.
Yeah. Let's think as of now. It's kind of it's a software. Yeah, I don't want to confuse you. It's a software. Yeah.
And for this also we required with physical machine operating system virtualization
Yeah.
software.
Yes. We are not going to create all the things. Okay, we are going to provision virtual machines in the AWS only. It's an easy process. It's a not time taking process. It's an easy process that anyone can do actually. Yeah.
Okay.
We are going to provision the virtual machines.
Okay.
Yeah.
Sir, Kubernetes will create like a mission also, sir. Like it creates like a application.
It will create. Yes, it creates a mission also. If you delete, see, there are different ways of creating Kubernetes clusters. Okay, there is a
Okay, sir.
KubeADM way or EKS clusters. Okay, if you create a KubeADM way, that will not create, because industry do not use the KubeADM way of creating cluster because of the disadvantages that it has. They will be using EKS way of creating cluster. Okay, in case of EKS way of creating cluster, if you delete one one virtual machine or one server, automatically a
Hmm.
new server will be created. Okay.
Okay, sir. Okay.
Yeah.
Yes.
Yeah, one general question, sir. Maybe not
Yeah.
this one. Normally, we
Okay.
take this course, right? After this, do we need to get some Docker certification from a third party, like say, Microsoft Docker Associate certified, or like that? Then only it is valued like that.
No. See, nowadays in the industry, the knowledge is required, not a certification. Anyone can do certification. Okay. So the knowledge on particular concept, whatever I feel I'm saying, what the knowledge on particular topic is required. Okay. Certification is a third part. Some people see the certification. See, in few companies use the certification to filter the candidates, but I may not believe that the knowledge is required for the candidates to work on that particular technology. Certification can be done in any way. Okay. So yeah.
Okay. So in that sense, no, let us say if we are completing the first Docker course, the first section of this course, let us say Docker, and if I want to go and get certified with Microsoft or AWS as a Docker
Okay.
associate, so all the
Okay.
content here is good enough for me to pass that exam, right?
Yes, it's a good enough for you to pass that exam. Okay. I suggest to like directly going and taking that exam, you take some tests first, so that it will be very good for you. Or yeah, that's your choice. Okay.
I mean, sir, there
It's
will be
enough.
mock tests. There will be any mock tests available in
Yes,
that?
yes. In the online, you can find the mock test, so that whatever the use cases, we are going to see the use cases that is
Mhm.
high enough for you to crack the exam. But if you want to take mock tests also, you can take you to understand the real exam. But yeah, I suggest that.
Yeah. Okay. And another thing is like whatever this environment setup, right? Dockerization, installing this Docker softwares,
Okay.
virtualization software. See, I have this brand new Lenovo laptop with me. So will I be able to set up that environment here in my laptop, or do we need to create an account on AWS Azure and do practical there?
Yeah, I suggest to create an AWS or Azure accounts, because if you these are the huge softwares. If you create, Docker is a huge application that consumes lot of CPU and lot of memory from your. It may slow down all the different applications that are already there on your laptop, right? So my suggestion is to create an AWS account or the Azure account and create a virtual machine there and practice there, because I will be showing in the same environment and you will be practicing in the same environment. What are the different problems I will be getting? Same problems you will be getting, and you will be knowing how to solve those problems. So if we follow the same environment in creating the containers or in deploying the applications, so that it will be very easy for you to follow up the things actually. So yeah, see, if you are deploying, so Lenovo is a Windows. I hope you are using Windows operating system. So
Yes.
yeah, if you can deploy Docker, but in case of Kubernetes, you definitely need to create an
Single
AWS account.
laptop may not be sufficient.
Yeah. Yes.
Right. So we'll go with an Azure or an Amazon account. So what recently happened, I'll tell you one thing. No, maybe 1 month before, no, I have created one Amazon account, one Amazon AWS account, and thinking that it's a free tier account, I'll be not charged anything. But and then no, when I was just trying to do these samples, installing Docker, trying the run, no, after month end, I got a mail saying you have to pay 2,000 rupees because you have used these many services. And then
Okay.
immediately I suspended the account.
Yeah,
So
I got to know. Yeah, because see, 1 year it will be free, but entire services will not be free. Okay, suppose if you are using a servers, okay, there will be a particular limit for that servers. So if you should fall under that limit, so that it will be free for you. If you fall over that limit, it will be costed for you. So it will be 1 year free. Okay, you should be fall under that limit, I mean to say.
okay. So whatever the services required for this course, no, all those services fall into that free account only.
No. Docker and Jenkins fall into free things, 1 year free things. But Kubernetes is bit costed. Like it costs you something.
Some amount. Okay. So whatever Jenkins and Docker practicals that we will create an account, it's going to be free of charge. We can do it. But at the moment when we switch to Kubernetes classes, no, for us to practice, do we need to purchase some services?
You no need to purchase first. You need to use that services first. They will generate some payment statement, and you need to if you want to pay, you can pay, or you can say that it's a as a beginner, I have created Kubernetes like Kubernetes cluster. You can say that. And what I can suggest, that is the reason, because of the cost reasons only. I have planned to create different ways of Kubernetes cluster, like KubeADM way, Minikube way, and EKS cluster way. I'm planned to create a Kubernetes cluster in 3 ways, so that it will reduce cost for you. Okay, so yeah.
Okay, fine. So with Docker and Jenkins, at least there is no problem.
Yes, with Docker and Jenkins there is no problem, because we need 2 or 3 servers only. Yeah.
Fine. And fine, sir. And another thing is that I am not a Java guy. I'm a C++ guy, and most of these contents, microservices, are explained considering Java. I just do not follow. When Java comes in between, I stop understanding the things. So I think it will be generalized.
Yeah, it will be generalized. Whatever it is, whether it is C++, whether it is Java, whether it is a .NET, whatever programming language it is, we are not discussing about the programming language. We are discussing about the common things for all the programming languages. Whether it is anything, Jenkins is a common one for all the programming languages. Docker is common one for all the programming languages, and Kubernetes is a common one for all the programming languages. Okay.
Okay, fine.
Yeah.
Hello,
Let me. Yeah.
Yeah, I'm from the admin background. Will it be okay if I join the class like just to learn the administrative part of that, and to deploy the Kubernetes cluster and the Docker images, etc.
Yes, it's okay for you. You will be getting knowledge how to do the things. See, from freshers to the very experienced people also can join this course. You will be getting clear-cut knowledge. We have keep in mind the fresher and the experienced people, and we have designed this course. Okay, it is suitable for everyone. Okay, that's how we design. It is okay for you also to join the course. No problem with that.
Okay, and do we need any programming background or something like that, like any prerequisites for this?
No. Any programming background is not required. While explaining in Jenkins something called shared libraries, some small things. It's not a complex thing. Okay, I will be explaining whatever it is. So a small thing like what is it? Yeah, like integer, something like that in programming. It's enough to understand the programming language. To understand the shared libraries in Jenkins. So it's not required any programming language. You need to know YAML file. How to write a YAML syntax, that also is part of syllabus. I'll be explaining how to write a YAML files, actually, what is a list and what is a key value pair, what is a dictionary in YAML. So that we will explain, we'll go through. Okay, that's an easy one. Okay, it's not a programming language, it's a static thing. Is that okay? Or
Sure.
Yeah. One thing, please wait, everyone. I want to share. I have got a requirement to share you these things. 1 second. If you have any questions, please ask.
Sir, when where we get these videos, sir? Like, will you share in the email? How?
This demo videos you mean to say?
Yes.
Demo videos, if you go to DurgaSoft website and go to the playlist section, you can find the demo demo videos there. Yeah, I have got a requirement to send this message to everyone. I have sent this one. So yeah, please go ahead and register for the course. And if you have any questions, please ask here. And that's what I mean to say. Yeah.
And how many days are now? Yesterday was first, today is the second demo class. And how many demo classes we have for this?
Mostly tomorrow and day after tomorrow.
Okay,
Yeah.
tomorrow and after tomorrow. Okay, and one last question, sir. This Docker, how many days it may take approximately?
It takes 15 days. 15 days.
15 days. Okay,
Yeah.
fine.
Or 10 to 15 days. Yeah, that's it.
Okay, and are we going to have sessions on Saturday, Sunday?
No sessions on Saturday and Sunday.
Okay, Monday to Friday we at the same time. Okay.
Yeah.
So can we join with the same link tomorrow?
Yeah, you can join with the same link. No problem with that. Yeah. Someone put what will be the duration? Okay, it goes to hi Haris. It goes from 45 days to 55 days actually. Yeah. Yeah, I have put the things here in the chat. Please go ahead and register for the course. That's what I meant to say. So if you have any questions, you can ask, or we'll meet tomorrow. Okay. Thanks for joining the session. Have a good day.
Okay.
Yeah, thank you.
Thank you.